There are some properties that let us compute the derivatives of more complicated functions. First, when you want to take a derivative of a constant times your function, you pull out the constant and deal with the derivative of just your function. For example, the derivative of 3x squared is 3 times the derivative of x squared, which is 3 times 2x, or 6x. Second, we have something called the sum rule. The derivative of a sum of functions is the sum of the derivatives of the functions. In other words, we can split up the derivative across the sum. We can do the same thing with differences. The derivative of a difference of functions is the difference of the derivatives of the functions. You're probably wondering, what about multiplying functions? Do they work the same? The answer is, unfortunately, no. But we will learn a rule for products soon. Let's try combining the rules and properties we learned to compute derivatives. For example, if we want to find f prime of x for f of x equals x to the 7th plus 3x to the 4th minus 2x cubed plus x plus 10, we can find the derivative of each part separately, pull out the constants, and then apply the power rule to each part. Our derivative will be 7x to the 6th plus 12x cubed minus 6x squared plus 1. Notice that the 10 went away because the derivative of a constant is 0. Another example. Find the derivative of 1/4 times x to the 4th minus 16 plus e to the x over sine of 2. This may look hard, but remember your rules. For the first part, you can just take the derivative of the inside and leave the 1/4 alone, so you get 1/4 times 4x cubed minus 0. For the second part, notice that sine of 2 is just a number, or in other words, a constant. Dividing by sine of 2 is the same thing as multiplying by 1 over sine of 2, so we really just need to take the derivative of e to the x, which is e to the x. So we get e to the x over sine of 2 for the second part. This is now our derivative.